I'll try to show you guys how to use sunpath in Ladybug in 1 or 2 videos. Each one probably will be 15 minutes. Let's see. So sunpath is here in Visual as Weather Data. You can grab it, bring it here, and what you need to have a sunpath is basically the latitude of the place. So if I import the latitude, like just so, and I need to visualize the results, so I get a mesh here, I connect the sun mesh, and then a geometry, so then connect the rest of output here, like lesion that I want. So if I zoom extend, you can see the sunpath here, and the data here is already default, set as default, so that's why you get the sun too. So the sunpath diagram for the latitude 32, 21st of December, 12 o'clock at altitude is this, the altitude of sun, and the azimuth is this at the time for this location. But usually you don't input a number like you have and change it like what I'm doing right now. You have a location that has a latitude. You can find that number from a weather file. There are different ways. You can definitely Google it and just do it like I did. But if you want to do it using Ladybug, you can do this too. So I have the weather file address here for Chicago. I just connect it here. It gives me the latitude as an output. So I can connect the latitude, and this is the sunpath that I get, and I think it's so big right now. So let me change the scale. What happened? Okay, better. So here's a sunpath with a better scale. So I will start from the top. So you have the Norse. The Norse input allows you to change the orientation of the Norse. So you can change it with a number. Like if I say 15, it will rotate the sunpath for 15. And then all the way. Or you can use a vector. Vector to Norse. Like all the way back. So it gives you a good flexibility that if the Norse of the project is not in the right, like is not Y axis, so you can just customize it. You can just change it as it is in your project. You don't need to rotate all the project to set to the sunpath. And then you get the longitude and time zone here. These two inputs are basically useful if you want to get the exact location of the sun. So here we're using Chicago. Chicago is in Midwest, and it has its time zone, which we can find it here. Time zone is -6 hours. So you can rate these two numbers and just put it here for now, but like for the next release, you will get something like this. Thanks to Brian, because he asked for it. And you can connect the location, and it basically explode the locations for you. So it exploded, and it just like decompose this string in different outputs. So I can use the latitude from here, longitude, and now I'm connecting time zone. So just look at here what's happening. It will move the sun a little bit, right? So this is all the difference. And in many cases it really doesn't matter, but if you want it to have it more accurate, this is the way that I'm just showing. Then you get some inputs here for hour, day, months, and time of 7 analysis period. These inputs letting you to have the right sun position that you're looking for. Because whenever you draw the sun path for this sun, you get the vector out of it right here. So this is the sun vector for that time, and if I change the hour, so as soon as the sun changes, this vector is changing, and this vector is useful, right? Because you can use this to start designing, and basically that's why you're looking to the sun path, because you want to know where the sun is, and why you want that, because sun is the source of energy for you. It brings the radiation and it brings the light. So to know where the sun is really important if you want to design something environmentally. Um, but there's no reason that you look at the one location of the sun at the time. You can have a series. Like I can select the series and connect all the numbers. So if I start from 1 and go to 24 for 24 hours of the day and just connect it to the hour, so it will give me all the sun positions during that day and months for all these hours, and here I get the output for all of them, right? And I get the altitude and azimuth if I want to use it. I think this is something interesting about having a sun pass in Grasshopper, because as soon as you get, excuse me, the sun positions, you get uh, the vector for that. But in a normal way, you have to go read the sun pass, find the degrees, and then you usually don't get the vector, but you calculate the HSA, horizontal sun angle, like solar angle, and VSA, which is vertical solar angle. And then, for example, you use that for this shading design or something like that. But having this information inside Grasshopper, as soon as you have the sun, you have the vectors. And you can draw the lines if you want, like for a better visualization. So I connect the center point of the sun path to the sun positions, and it gives me these lines, which are the sun vectors. And I can loft them, so it gives me the sun, the solar fan. Here you go. Let's change the color. Not this color. Here you go. Let's do it a little bold. Okay, so I get the sun fan, and now I know, for example, if I want this point, get see the sun during all these hours, how I should cut this building. So let's just cut it actually. So I can select the building, and then I can find the intersection. BRAP. Here you go. This is that line. Probably you don't want to cut that building, especially because this is December. You usually need the sun at December. So let's go for another month. 6. Oh. So this is the line now. And I can trim it right now. I can trim this building with this line right now if I want, but I'm not going to do that. So you see how you can easily find the intersections and understand, like use it for presentation to say, okay, if we want to change the design to see the sun at these hours, this is the way, this is how we should cut the building. And before I get, so I have 5 more minutes to get to 15 minutes, so let's finish this part and I will leave the rest for the next video. So now I found the sun path, right? And sun positions on the sun path. I draw the sun path. But usually you're looking to sun paths based on some other data. And the other thing that you want to know is okay, what is sun position actually telling me? When is that and where is that? So that's why you get the sun position information here. You can use this and you grab a text tag. Let's do the 3D one. Connect the information to the text and use the sun position as the location. And now I can read it. So, oh, okay, so this is May. I cannot read it fully. So May 21st, 2 p.m., 3 p.m., 4, and then as soon as I change this, it will change. But as you see, it doesn't really orient it to the camera. It just oriented to the work plane. Then that's why you get this camera up here. I can do this. Use the current position, connect it here. It gives me the new plane, and I can use for the new location. So now it really orients the camera, but it doesn't update itself, so you need to use a timer. Let's do it 500 milliseconds. And now, as you see, when I move it, it just follows it. So let me deactivate this one and talk more about this part. So as you see, you can do it for the whole day, but you can even do it for the whole month. I mean, you can do it for all the hours. Let's get more space here. So you can use another series. One to 31. And then I just connect this to the day. Wow. And let's deactivate the loft. So now I get all the sun positions for that month with the informations, and it's now it's sort of being. So I just changed the scale, and the sun itself doesn't look in the right scale that we want. So you can change the sun scale here. Here you go. Yeah, so you have a really good control on the visualization of data any ways that you want. You can just show that surface. You can here you can disconnect the curves. You can connect them. Whatever you want to do. And but sometimes you want to have it for more than 1 month, 1 day or something. I mean, you can still connect the series here. I can do like from months 1 to 3. So let's for this time I just write them 1, 2, 3, and then I can connect it here. And as you can see, I get the sun. I think this is so small right now. Okay, so I get it for the months 1, 2, 3, right? But instead of doing something like this to have all these inputs, you can just not use this tree and only use analysis period. So you can use the analysis period component here, and you can say from month 1 to 3, and it will give you the same result. As you see, and I can so let me add 2 more months. The sun should go this way. It goes that way. So this is how it works up to here, and it was mainly about the visualization and how you can use it, but how really you can use it for design is going to be what we're going to talk about in the next video. Thank you for watching this one.